Kia ora Year 12. This video is a request from Eaton for one of the locus patterns that you guys saw today. And it's one where I'm going to do it in two different ways. I'm going to do it using geometry, and then I'm going to do it using algebra. And if you're doing this for level 3, you need to make sure that you do it using algebra and just apply the definitions. Now, I'm sorry, but this one is going to be accompanied by noises from the kitchen, the singing lesson, and probably the dog. So we'll just see how we get on. Okay, let's look at what this means before we get into the algebra. So we've got some point z, and we're going to rewrite that left-hand side as this. Z minus -1 plus 2i is equal to z minus 2. So we can think of this meaning the distance, right? So the distance between the point and this point has to be the same as the distance between the point and 2. So let's start by just doing a really, really bad graph of where those 2 points are and see if we can work out what that locus is going to be. E. Right, there you go. You can probably hear the scales in the background. Right, okay. So this point here is 2 plus 0i. So that's sitting here at coordinates 2, 0. This one here is -1 plus 2i. So that's sitting about up here. I've got a GeoGebra of this for the final product, but let's just have a look. So my locus is the set of points that are equal distance between those two things. So we know the first point that's going to be equidistant is the midpoint, right? So let's whack that onto my graph. Where's the midpoint? Well, we've got -1, 2, and 2, 0. So the midpoint is at -1 plus 2 on 2, 2 plus 0 on 2, right? So this is your level 2 coordinate geometry stuff. It's just in a complex numbers context, right? But that's what we've got. So my midpoint is at 1/2, 1. So that point there is on my locus. And if you think about it, the perpendicular bisector of those 2 points is going to be the locus that we want. All right, so let's draw that in, and then we're going to find the equation for that. Okay, so this is if you're doing it for A level. It's fine to use this logic that you'll spot this pattern type where one distance is equal to another distance. And you can see that that midpoint's on there, but if we just trace out these points here, that point there is also going to be equidistant, especially if I'd actually used a decent grid. So that's what my solution is going to be. So all I've got to do now is figure out what is the equation of that line. And that's not too bad, right? Because we know the gradient. If we call that AB, we can find the gradient between A and B. So that's the change in Y divided by the change in X. So going back to like year 9, finding the gradient, I have gone down 2. So it's 0 take away 2, change in Y over the change in X, 2 minus -1. So that gradient is -2/3. That means that the perpendicular bisector gradient is equal to 3/2. So we know that, and we know that the midpoint is on the line. Moving over here to get some more space, that means I can work out y equals mx plus c. So y is equal to 3/2x plus c. Substituting in this point gives me 1 is equal to 3/4 plus c, and c is equal to 1/4. So my final equation is equal to 3/2x plus 1/4. So there you go. Now, I've done that using, I guess, what I call a geometric approach. What I'm going to do now is apply my definition of the modulus or magnitude and start by saying let z equal x plus iy. And you'll see we come out with the same thing. So I'll just shrink this down so I haven't lost what those points are. I'll get rid of the last video I did. There we go. Right, so we've got z minus, so z plus 1 minus 2i is equal to z minus 2. So what I'm doing now is what I call the zero intuition approach, where we just say let z equal x plus iy. And this is what you expect to do if you're doing level 3, right? So we need to show these substitutions. We've got x plus iy plus 1 minus 2i is equal to the magnitude of x plus iy minus 2. Just checking that I've got the question written down right. Yep. So you'll notice that this time I haven't rewritten this bit here. I'm just leaving it how it is. The next step is to group the real parts and the imaginary parts. So we've got x plus 1 plus I times y minus 2 is equal to x minus 2 plus iy. The modulus is simply Pythagoras. So it's x plus 1 squared plus y minus 2 squared is equal to x minus 2 squared plus y squared. I'm going to square both sides. Okay, we've moved on from the kitchen. We've got the singing noise in the background now. But the dog has been quiet, so that's good. Okay, now comes the tedious but good practice. I need to expand out all of those quadratics and then simplify terms. So pause the video and do that now in your book. And you should end up getting the same equation that we got before. Be really careful that we've got y here, not x. X squared minus 4x plus 4 plus y squared. Now I'm going to simplify. So this and this go, this and this go. Right, 2x plus 1 minus 4y plus 4 is equal to negative 4x plus 4. Let's just get rid of a few bits here. Okay, 6x minus 4y. Adding this to both sides, 6x minus 4y equals negative 1. Rearranging, oh, I don't know if I've done this right. I've lost something. I've got 4y is equal to, oh no, we are right. 4y is equal to negative, 4y is equal to 6x plus 1. Y is equal to 3 over 2x plus 1/4. So look at that. Happily, we've got the same as what we had before. I've erased it when we did it just using geometry. Okay, so again, if you're doing this for level 3 and you're somehow watching this and you're doing level 3 complex numbers, you need to do this substitution approach. Okay, last thing I want to show you is the GeoGebra for this, which is sitting over here. So if you look at that GeoGebra screenshot, I don't know what that thing is doing there, but forget about that. You can see that here I've given you these 2 points to start with. Right, and again, what we're looking for is, if I join those 2 points up, joining up A and B, then this is my locus, right? So that's my perpendicular bisector, and you can see that everywhere on there, if I measure from here, it's going to be the same as the distance from there. So there you go. So Ethan, I hope that helps. Let me know if it doesn't. And thanks for doing the video request.